Hi, everyone. Hey, Jake. Hi. Just waiting for everyone to come back in. So today, I'm going to kind of take off where Mike left off, and I'm going to talk about the coveted universal web component format, what that means, maybe some solutions that exist today, and maybe what we're going to do in the future. So just so we're very clear what universal means, I mean that no matter what framework, I'm sure that we've got people here that use Angular, React, Ember, Backbone, Vanilla.js, they're using Dojo, whatever it is you guys use. I want to be able to create my web component and have it be used by everyone in this room. Doesn't matter what framework you're using, doesn't matter if you're sharing with the community, sharing with different teams. Basically, I want this. So that leads me into who am I? Why do I care about this in particular? So I'm Jay Phelps. I'm a software engineer over at Netflix, work on front end. I actually work on back end, front end, in the sense of insight tools that monitor the performance of the Netflix edge, or basically the architecture, which, if you really think about it, is actually a really, really difficult problem to solve. We've got a lot of stuff, we've got hundreds of apps, and there's something I wanted to make very clear, because every time I talk to someone always says that they read our blog and they say, oh, I thought you guys only use React. So Netflix does not just use React. We love React. I personally love React. There's a lot of really great things about React, and for what they're using it for on the consumer side of things makes perfect sense right now. But we also use Ember a lot. We use Angular, we use Backbone, we use Polymer, we use the whole gamut of things. Some of you may have heard a lot about Netflix's culture, and we advocate freedom of responsibility. Basically, you choose the technology in which you want to maintain. And so there's small teams, and they choose the technology stack that they want. And everyone's got different opinions, and there's a lot of wars right now between the frameworks, but there's also a lot of love. And where that love is going is basically web components. That's going to be the biggest thing. So you learned about what W3C web components means in Mike's previous talk. So it's just basically creating custom tags with custom templates inside of it, being able to basically encapsulate all of your JavaScript and your CSS. So he did show some examples. What happens in the real world when you try to use these features right now? What is missing? And some of you may have caught it. Some of you may already know all about web components, and probably some of you may know more about them than I do. But what we're missing, I'll give you a hint. There is no interpolation. The word interpolation does not come up at all in any of the specifications, at least in relating to the template tag. The template tag itself is inert HTML. That's it. So you can't put you can't put some magical placeholder directive or curly braces like you're used to with handlebars or mustache or whatnot. You can do that, but you have to manage it. There's no browser. Nothing comes for free. So if you don't have any built-in interpolation, initially you might react a little bit like this. So what else are we missing? We're missing bindings. If we don't have interpolation, we don't have bindings, right? So even if we did have interpolation, maybe you think, oh, I'll troll you, Jay. I'll use my curly brackets, and then I'll use I'll look inside inner HTML and do string replace and replace them. Sure, great. But then what happens when that value changes? You no longer have bindings. So if you're used to Angular, React, Ember, any of the great frameworks, you've just lost that. So.
Too soon, man.
What else are you missing? And I'm trying to explain that basically you're missing a lot. They punted on a lot of things. And it's understandable, right? Because if you look at the syntax that's required to do this in Ember, compared to Angular, compared to React, compared to all these things, they're very different. They are very different. Some of you may have not been familiar, but the syntax I used earlier is based off Mustache, which is used in Handlebars, the same syntax. But how you do bindings in Angular is very different. React is almost the same, except for you have one less curly bracket. So we're missing bindings, we're missing interpolation. Our templates are basically just a nerd HTML. What do we do? So let's start filling in these gaps. It's a couple of years ago, people are talking about the W3C components. Mozilla, Google are working together, they're talking these things through. Mozilla comes up with something called XTags. And so what is XTags? Well, first thing they did is they made a bunch of polyfills. Now, if you guys have been doing modern web development, you probably are using polyfills somewhere. Maybe you don't even know you're using them, but you probably are. So they polyfilled the custom element, they polyfilled HTML imports, and then they added this layer, this very thin layer on top. It looks pretty thick in the diagram, but in reality, it's actually rather thin. That basically gives you a little bit of sugar. And what does that sugar look like? Well, here's just a very simple example. You've got your lifecycle hooks, and you've got event listening for delegation and togglers and methods and stuff like that. So this basically gets boiled down to what Mike showed earlier, and then also works cross-browser. What Mike demoed earlier works today in modern Chrome and in Firefox behind a feature flag, but doesn't work in IE, doesn't work in Safari. And so they created those polyfills. They created this nice little sugar, but I don't know about you, but this didn't solve the problem we were just talking about, so I want more. Google came out with Polymer, and it is awesome. It is really, 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 really cool. I'm going to say some things later in the talk, and I don't want to discredit the Polymer people if they ever hear this talk or ever hear about this talk. I want them to really know that I really think it's incredible. It checks off one of our boxes. It's got declarative bindings. This is what they look like. So we've got our little mustache syntax just like there. So counter will actually output there and actually will be updated when we change the counter. And then we've even got one up. We've got event handling inline. So I can say increment, and in this case it's a function. And so when on tap, when you tap that button, either on a mobile device or on a desktop, it will call increment. Really cool. So we're good there. It's got computed properties. If you're familiar with Ember, Ember's got a really robust computed property system. This is similar in concept, except for how you declare it is within strings. And it's a little more limited, but it's pretty powerful for the very basic cases. So we'll go ahead and say, good enough. It's got observers. If one of your properties, like better or best, changed, by convention, all you have to do is basically have a method on here that's basically suffixed with the camel case changed word. So better changed will be called when better changes, which is, makes real sense, right? Combining all of those things, what does it look like when you're defining a Polymer component? You use this custom syntax, which it is itself a component itself, as you can see. And you can expose attributes. You've got your styles for your templates in here, just like Mike was showing. You've got this little helper Polymer where you define the actual, basically the prototype of your elements and set up all your JavaScript. And we're all good, right? So Polymer lets you do what Mike was showing you, plus all the existing things that we have today, for the most part, with Angular, Ember, React. But there's one problem. Well, there's a couple problems, but the most important problem that I ran into at Netflix, and I've run into before, is that it's all fine and dandy if you're making menus, hamburger menus that sweep out and in, and even stuff that requires some basic increment and decrement and stuff like that. But what happens when you actually try to do something pretty complex? How many people here have actually written, used like D3 or some sort of charting library and actually done like a chart, right? So it's D3 and those type of libraries are just a godsend, because if you've had to write them before without them, it's a pretty difficult task to keep track of. Now, what if you wanted to build that in a way that was actually componentized and not using just this giant D3 spaghetti code of magic? Basically you can create a line component, and you can create a scrub, and you can create a legend and all these things and let other people compose these things together. And you just use SVG under the hood, and it's all magic and all dandy. Well, there's another example which actually, has anyone here heard about the recent Ember Glimmer announcement with the rendering engine? Okay, some of you. So there's a performance war going on, if you haven't noticed, and it's primarily with Ember and React. Angular's definitely in there, but in the news-wise, I've been hearing, at least I'm hearing mostly Ember versus Angular, and they go neck and neck, back and forth. They keep getting better, and React has been basically in the lead most of the time. I don't know about any of you, and please, if you've heard major things, please come tell me after. But I haven't heard anything about Polymer fixing or making really big strides on performance for rendering. Because remember, we've got templating now. We've got bindings. We've got loops that I didn't show you in here, but Polymer actually has the ability to do loops, just kind of like an each helper. It's very similar syntax to Angular with their directives. So if you've got this giant table, and I'm sure that Mike and Steph, the guys from Yahoo, can attest to, if you've got a giant table of data that is updating very quickly with a lot of different data, you're starting to run into some performance issues. Re-rendering is not the most performant thing in the world in Polymer. And it's not a huge knock on them, because guess what? There's a lot of things they're solving. The technology came out I don't know the exact date of when it came out, but it's definitely not super recent. And they're aiming to solve more as an R&D experiment. They're focusing on different things than performance. They're not even in the performance wars, as far as I know. Please correct me if I'm wrong. So we found that when we started to use Polymer to test to basically extract some of our charts and some of our tables so that other teams within Netflix can use them. So we've got these great charts, we've got these great tables. We want other teams that are using Angular, React Backbone, it doesn't matter, maybe server-side MVC, like a traditional architecture. We wanted them to use these things. But we can't with Polymer. It was not giving us the performance we needed. The other gripe, which is it's less of a gripe, and some of you guys can definitely think of some rebuttals. But for me, I have become accustomed to the awesome ES6 syntax. And not only ES6, I've been a huge early adopter of ES7 as well. And the plus basically means features that are not necessarily been discussed in ES7, but are actually implemented by some of the transpilers. So what do? We're kind of back to square one if you're trying to build real world, high efficiency, shareable components. What now?
jQuery.
Go back to jQuery, raw metal. And that's actually what we're, ironically, kind of what we're doing in some cases. And what I've done in the past is sometimes basically you drop out of your framework and you go back to your bare metal JavaScript. You don't use bindings. You actually just literally by hand type the code to actually replace the values and manage your reflows individually, which works, right? But it's not the most beautiful thing in the world, and it's a pain in the butt. That's why we created these abstractions in the first place, is to save us from having to do that. So I started to think about this. It was actually one of the reasons I was hired, for many reasons, but one of the reasons I was hired, tasked to be able to abstract these type of things and let more code reuse within Netflix while still letting people use independent frameworks. So I started with the knowledge of knowing that React and Ember are super fast with rendering. There's the caveat with Ember being fast once Glimmer is actually in there. And Ember is pretty fast, but it's still not fast enough. But once Glimmer is merged, it's going to be neck and neck with React. So I looked at React, and I've used React in the past. And it's rendering, how it does its virtual DOM diffing is genius, it's great. But how they wrote the project was not intended to be used and consumed outside of itself. It was not, there is no clear, easy way to use it with actually the web component story. It kind of has its own concept of a shadow DOM. It kind of has its own concept of custom elements that has nothing actually to do with W3C. It's inspired by it, but nothing to do with it. So I looked at Ember, and I know that Ember has HTML bars, which is what's making, like a majority of the TLDR on that is majority of the performance comes from HTML bars. And HTML bars is not actually a part of Ember, like it comes with it, but it's a totally different project. being maintained separately, and I thought, can I use this really fast templating and just kind of use the W3C tags and shove HTML bars in there? Like, can I use this? This is really, really cool. Yep, I can. So I wanted to give you a little quick taste of something that I'm working on. It's called Graffiti, and this is what it looks like. It's a framework for creating universal components that uses HTML bars behind the scenes, but your component itself doesn't need to actually know that. The consumer of your component doesn't need to know that. It's not dependent on Ember in any way whatsoever. The runtime that it ships with, if you pre-compile your templates, is super minimal, and it's fast. Now let's take a look real quick at some of the code. We've got register element up here to register our custom tag. This is using ES7++ syntax. So some of you may not be familiar with this. This may look like, like alien language, or maybe C# or maybe Java, if you haven't been following the ES6, ES7 stuff. But very soon in the next couple of years, if you're not already using a transpiler, very soon you will be writing syntax very similar to this.
The at stuff is going to be finalized basically next week.
Basically. And so we've got our ES6, ES7 syntax. So that's awesome. And by the way, for those Angular people who follow what's going on, yes, this does look a bit like Angular 2.0, and that didn't happen on accident. Well, it happened on accident in the sense of I actually had not looked at that syntax, but we basically came to the very same conclusion in a lot of ways. We're both using decorators, which is this at syntax, which very similar to concept as annotations in some languages, but they're actually more powerful. If you're familiar with Python has decorators, and they work almost identical. This is something that's going to probably be, like Steph said, codified and actually determined very, very soon. In the next week, they're meeting about it. So what about bindings? Because I was stressing bindings earlier. Jay, what can I do? Well, we've got HTML bars behind there, so we can do, just like in our previous Polymer example, we can do counter output, and we can create our own little helpers. Graffiti itself has an on helper, so you can do event delegation. The event will actually delegate to the component itself, the root, basically the shadow root. And basically this increment function that's on the component will get called whenever the click event has its own button. Here's our CSS here, just like he was showing earlier. We've got the host pseudo tag, we've got counter val, but also look in here. You can actually blind in your CSS as well, which is neat. Something that a lot of people aren't familiar with. So if you're going from Ember or React, you can actually do that. So you can actually bind your CSS in your style sheet. Now you got to be careful about this. This is something that's very new. Polymer actually can do this there's a component that lets you do this very similar, almost exact identical syntax. But you got to be careful because there are some CSS exploits that can happen, and I'm still undecided whether I'm going to ship a 1.0 with this ability. Because if you're paying attention, it's okay. But the problem is HTML bars is aware of your HTML, but in here, it has no idea. It's just a string, right? So it has no idea that you're doing PX right after these curly braces. It doesn't have any context of CSS. So if font size was provided by the user, stored in the database, someone could inject CSS, which, depending on what browser you're in, if you have IE behaviors, they can load arbitrary HTC, I think they're called HTC, it's been years since I've written those, but I know that IE still supports some really crazy stuff in CSS to be able to actually.
It's not only IE, you can XSS from CSS.
Yeah, you
can also escape out of the CSS.
You don't want to do that.
Yeah, so you got to be careful. And so there's lots of talk about this. I'm not going in blind to it. The quickest solution. Everyone always types in when I talk about this with other people, like, oh, just put a CSS parser in there and have it context aware. Easier said than done. And we don't want massive performance issues and stuff like that. But the goal of this project is ES6, ES7, and to be fast, super fast. It's going to be open source. Unfortunately, I can't make it open source right this second. And the biggest issue with it is actually not because of implementation being finished, but actually because I'm actually depending on TypeScript right now for all of the syntax, because the decorator pattern that I'm using does not exist in any of the other transpilers. I advocated for Babel to add it, but they won't budge until TC39 actually says, it's basically 2 weeks. So very soon I'll be porting it over to Babel, because I love TypeScript, but I don't want to force TypeScript on other people. So I'm just going to demo it really quick just to make sure, in case you have any naysayers that think that I just typed up some fake pseudo syntax and just said, like, I've got a project, it exists.
But how fast does it spin blue balls on?
I was totally going to do that, but I didn't even think about it until today. I was like, oh man, I should have done this spinning blue
Clearly
ball
it's
thing.
too slow. So.
Yeah, clearly. Well, the performance will be as fast as Ember, if not faster, actually, because there's less overhead that needs to maintain. So let's go in here. I'm gonna go ahead and throw this up here. And this is, sorry about that. This is the code I was showing you earlier. One thing you'll notice is I am actually exporting, and then I'm doing the TypeScript imports, which is the same. This is a special, this is not only just TypeScript, this is a special branch of TypeScript, the demo branch. So you can't check it out via NPN, you have to basically copy and paste it, so hence why I'm not releasing this today. But this is real code. And so here's it is, it's incrementing, and guess what, console logs. And just to prove this is actual real code that you can compile and change, I'm gonna go ahead and change this to, like, a bunch of characters or whatever. Come into my terminal here. There we go, now build, done. Over. And there, you can see, right down there. But I changed it. So, long story short, I wish I could give you a better demo, but because of time, and I didn't want to make the entire talk about this thing that I have not yet open sourced. That's the gist. And that's all, folks. Thank you.